question is about factors. So this is a complicated question. Just pause the video and read. So after you read the whole paragraph, you should know that this length is 4, this length is 4, and it's perpendicular here. This is the midpoint, so in the middle. And this length is 3, this length is 1, and we know that the ratio is 2:1. And now we're finding MD and ON. The fastest way to find MD is from M to D. So we can go from M to D through this path. So we go in this direction, which is minus 2I, because it is a half, so this must be 2, and the direction is minus I. And from here we go to this direction here. Again, it's midpoint, so it's a half of 4, 2, and the direction is opposite of J, so minus J, minus 2J. And then from O we go upwards. The direction is K, magnitude 3, so minus 2I, minus 2J, plus 3K. Just like that, we find the factor MD. Or alternatively, you can do it manually using the longer method, which gets the same result. Now for the factor ON. So for ON, we go from O to N. We can just go from O to this foot of perpendicular. Okay, why is it 3? Well, because we know that the whole length is 4 and this length is 1, which means this is 1, which means this is 3, and due to the ratio, this must be 1, this must be 2. So we have 2 plus 1, which is 3. So this is 3 and this is 1, again because of the ratio. This is 3, this is 1, this is 2. So this is 2 and this is 1. Right, so from O to N we can just go in this direction 3 units, so 3J, and upwards 1 unit, which is 1K, so 3J plus 1K. Or you can just do it manually, analyze the ratio and use the factor rules. We get the same result. Now to find the angle between MD and ON, previously we know MD and ON factors. We have the MF19 formula. If you modify this, you get this modified MF19 formula. And now we apply it here to find the angle between MD and ON. So factor times factor dot product, we use this formula. So we do minus 2 times 0, minus 2 times 3, 3 times 1. And for the magnitudes of minus 2, 3, we do this. Magnitudes of 0, 3, 1, this is what we do. And use a calculator, use inverse cos, we get the angle. Now show that the length of the perpendicular from M to ON. So if we know A and B, of course we can find M because it's in the middle. So OM is 2 to 0 because we go in this direction 2 units and in this direction 2 units, so 2I plus 2J and 0K. To find the magnitude, we use the usual. And for the point N, so for the point N, we go in this direction, which is 3J, and this direction, which is 1K. So that's 0, 3, 1. To find the magnitudes, we use the formula, we get this. Now if you look at the OPM triangle, let's say this angle is alpha. To find the angle alpha, we can use the factor OM and the factor ON. So remember, the direction should be from the same point, starting from O to M, starting from O to N. So using the dot product again, the factor on and om, you can find the angle alpha, or you can find the cos alpha. Okay, so this is still cos alpha, this is not the angle alpha. And then if we draw the triangle OPM, we know the alpha trigonometric ratio, because cos alpha is 3 root 5. This is cos adjacent over hypotenuse. Okay, so we know it's 3 root 5 over 10 from here, so from cos alpha. And if we know the two sides of a right angle triangle, we can use Pythagoras to find the other side. So from here we can find sine alpha, tangent alpha if we need one. So now if we look at the ratio PM divided by OM, or the sine actually, this is the same as root 55 over 10 because of the ratio of the lengths. Now the length PM is, therefore you multiply both sides by the magnitude of OM. We already know the magnitude of OM is 2 root 2. This is the OM magnitude. So therefore we can just use a calculator here, but since we need to get the form, we need to show, which is the square root of 22 over 5. Let's just do it manually. So we can cancel out the 2, and the 10 divided by 2 is 5. So we have 55 times 2 is 110. So root 110 over 5, or root 110 over 25. And if you use your calculator, divide by 5, we get 22 over 5, which is what we need to prove. Alright, I'll see you again next time.